Okay, my iPad ran out of space because of all the filming that I've been doing, and so what I wanted to do is go over this next one again, and we're going to complete this page, and then we'll go on to the next page after this. So we're still dealing with isotopes, and isotopes have the same number of protons, different number of neutrons. But since we're changing the neutrons, we're changing the mass of the nucleus, and we're changing the mass of the atom, so it's going to have a different mass. What happens if the number of protons changes? If you change the protons, you're changing the atomic number, and that changes the element. So indicate the number of protons and neutrons and electrons for isotopes of the same atom. So we're going to take a look at carbon-12 and carbon-14. So we're going to create a list going down here and a list going down here. And we're going to take a look at the protons, the neutrons, and the electrons. So if you take a look at carbon-12, carbon-12 has its element number 6, and it has a mass of 12. However, carbon-14, okay, let's go back to this. This is the same number of protons. That's an isotope. So it's going to have the same number of protons as this carbon here. So they're both going to have 6 protons. But with an isotope, you have a different number of neutrons. So if the mass of carbon-12 is 12, and the total number of protons and neutrons have to add up to 12, how many neutrons will you have here? 6 plus what equals 12? You're going to get 6. But C14 has a different mass. So 6 plus what will equal 14? That's going to be 8. So really the difference between C12 and C14 is not the number of protons, it's the number of neutrons. So the protons have to stay the same because it's the same element. But the neutrons can change, and that will change their mass. How many electrons will these each have? Well, this is not an ion, so we're going to have 6 electrons here and 6 electrons here. So now we're going to be going on to ions. What does an atom need to do to become a positive or a negative ion? Now, if you're a positive ion, you have to do what with something that's negative, because we're dealing with the electrons now. Are you going to lose an electron or gain an electron to become positive? Do you lose a negative or do you gain a negative? To become positive, you're going to lose an electron, and to become negative, you're going to gain an extra electron. So how do you become negative? You gain the negatives. How do you become positive? You lose the negatives. So the next one was we're going to compare protons, neutrons, and electrons for positive and negative ions. So we're going to create a little a chart here. And on this chart, what I'd like you to do is to write Al for aluminum, and then Al with a 3+. This means that it's aluminum that has a charge of +3. Here's F for fluorine, and fluorine, this is going to have a -1 charge, so this is how it's written. I'd also like you to write at the top the protons, the neutrons, and the electrons. So take a look right now at your periodic table, and I want you to look at the number. What's the number of protons that aluminum has? Again, the number of protons is the atomic number. So what's the atomic number of aluminum on your periodic table? It's number 13. Take a look at the mass. The mass is 26.982. Well, that rounds to 27. So if this is 13 and we have a mass of 27, and the protons and the neutrons, these add together to make the mass. So we have a 13 here, and we have what here is going to add to a 27? It's going to be 14. Okay, now the electrons are going to be different because we're looking at an ion here. So how many electrons normally does aluminum have? Well, normally the electrons is going to be equal to the protons when you have a neutral atom. Neutral is going to have same protons and same electrons. So number of protons is 13, so the number of electrons is going to be 13 as well. Okay, so in this, we're not going to change the protons. We're not going to change the neutrons. What's changing in an ion is the electrons. What's changing in an isotope is the neutrons. So again, let's take a look at this ion. Now it's becoming positive. So how do you become positive? You're going to lose negatives. So this is going to have 13 protons, 14 neutrons, but how many electrons will it have? Well, it's either going to have to gain or lose. So again, how do you become positive? You're going to lose electrons. You're going to have to lose 3 in order to get that. So you're going to have 13 protons, 14 neutrons, and 10 electrons. Let's say you've forgotten about, well, I can't remember if it gains or if it loses. You can always put these charges right here. There's 13 positive protons and 10 negative electrons. Let's add 13 positives and 10 negatives together. What does that give you? 13 and negative 10 give you a positive 3. Let's say going back to 13 here, we thought, well, I'm seeing a 3 here. This is going to be probably either 10 or 16. Well, let's say you make it 16 and you wrote a 16 down here. 16 negatives and 13 positives would give you 3 negatives, and that would not be correct to do it that method. So let's go ahead and do this next portion with the fluorine. Again, looking at your periodic table. Can you find the number of protons, neutrons, and electrons for this? Look at the periodic table. What's the atomic number for fluorine? That's the number of protons that you have. Fluorine is atomic number 9. Now the number of neutrons is dependent upon what's the mass. The mass is 18.998. That's going to round to 19. So 9 plus this will have to equal 19. How many neutrons is it going to have? Remember, the protons and the neutrons added together are going to create the mass. It's going to be 10. This is neutral fluorine, and when it's neutral, the protons are going to be equal to the electrons, so this is going to be 9, and it's going to look like this. And again, with an ion, the protons aren't going to change, the neutrons aren't going to change, it's going to be the electrons. But it's going to become a negative charge. How do you obtain a negative charge? Are you going to gain an electron or lose an electron? You're going to get more negatives. You're going to gain an electron. Regular fluorine had 9. So if it has a charge of 1, it's going to have 10 negatives. We can check this number because we have 9 positives and 10 negatives. 10 negatives and 9 positives will give you a negative 1. So that's isotopes and ions. We're now going to go to periodic groupings, and this is the directions of the groups. Now the groups are also called the families, and these guys are going up and down. So we're talking about group 1, group 2, etc. Group 1 are your alkali metals. Group 2 are your alkaline earth metals. So the direction of the groups, these guys go up and down. So these are the elements that are in the vertical columns. Okay, what is the direction of the periods? Well, the periods, these guys go across. These are horizontal. This goes from the left side to the right-hand side. So period 1 consists of the very top row, which is hydrogen, and then helium. Okay, the period 2 consists of the next elements, which are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. They go across the periodic table. What's the significance of the group number? We did a lab on this where we looked at all the valence electrons, and we found out that the group number is also equal to the number of valence electrons. And remember, the valence electrons are the outer electrons. Okay, one of our labs, if you remember all those numbers, group 1. So hydrogen had 1. Lithium has 3 electrons. 2 are in the first shell. 1 is in the second. That gives the outer shell 1, which makes it a group 1. Sodium underneath that has 11. 2 in the first, 8 in the second, that makes 10. If I add 1 more, that gives 11. That means the outer third shell is going to have 1. So they're all group 1s. So the name of group 1, an example. So these are called your alkali metals. And an example, this could be lithium, sodium, potassium, rubidium, cesium, francium, anything, but not hydrogen. Hydrogen is a group 1, but it is not a metal. So I'm just going to put Na here. So anything in group 1 except for hydrogen. Okay, so let's go ahead and put that, not hydrogen. Anything else in that first column is a group 1. Because remember, hydrogen is not a metal, it is a gas or nonmetal. Name of group 2, an example. These are called your alkaline earth metals. If you look group 2 on your periodic table, you can choose anything. Going down that second column, we have beryllium, magnesium, calcium, strontium, barium, and radium. These are all group 2, and we will just pick calcium as an example. Now, how to name group 3 to group 6. This is the top element. My lights have gone out. Okay, this is the top element of every group after that. Top element, okay, of the group. So group 3 is the boron group, moving over on your periodic table. Group 4 is the carbon group. Group 5 is the nitrogen group. Group 6 is the oxygen group. However, group 7 is not called the fluorine group. This is named after salts, and salt in Greek is halo, and these are called the halogens. So the halogens, an example of this is going to be fluorine. Name of group 8, it is not the helium group. These are called your noble gases. Example, the top one is helium. What's the name for that giant rectangular block of metals? These are called your transition metals. An example, if you look anything inside that giant block, element number 28 is nickel, but you could have also done 29, which is copper. You could have done 30, which is zinc. You could have gone down to 80, which is mercury, gone back 1, 79, which is Au, gold, anything in that giant block. Where to find metals on the periodic table? Are they on the left-hand side or the right-hand side? They are on the left-hand side. Where to find nonmetals? You find these guys on the right-hand side. Now take a look at table salt. Do you guys know what's the symbol, what's the formula for table salt? It's sodium chloride. It is NaCl. Well, metals are found on the left, and in NaCl, Na is the metal. Notice how Na is on the left-hand side in the formula. Okay, and then your nonmetals are found on the right-hand side, just like the chlorine or the chloride in sodium chloride is found on the right-hand side of the formula. So they actually, ionic compounds are particularly written that way. So if you can remember table salt as NaCl, it's a metal, nonmetal. Metals on the left, nonmetals are on the right. Why do noble gases not react with any other element? Or why do other elements react with others? So noble gases do not react with others because it's their outer shell. Their outer shell, or their valence shell, is complete. They have either 2 if they're helium or 8 if they're anything else. If you have a full shell, so is complete, we can also say full. Their shells are full. Why do other elements react? Other elements do react because their shells are not complete. their shells are not full. So they react with other things to become complete. Why do alkali metals and halogens react more quickly than other elements? Well, alkali metals, what group are alkali metals? These guys are group 1. Halogens are group 7. Group 1, these guys to react, these guys are going to lose 1 electron. Group 7, these guys are going to gain 1 electron. And they do it very quickly, they do it very, very easily. If you remember from the video of hunting the elements, they showed sodium, potassium, rubidium, and cesium, and francium, and the explosions that they create. These guys lose the 1 electron very easily. Group 7s, like chlorine. Chlorine, it steals electrons. They gain the 1 electron very easily. So alkali metals and halogens react more quickly than other elements and are more reactive and more explosive they can be in certain cases like this because they only have 1 electron to gain or 1 electron to lose. Last concept is going to be bonding. And this was very similar to what we saw in the most recent handout. Definition of a covalent bond. What do you do to have a covalent bond? You are going to share the outer electrons or the valence electrons. Ionic bond, we're going to either lose or gain the electrons. So bonding really deals with the electrons. It doesn't really deal with the protons and the neutrons. It's all with the shells and the electrons in those shells. And they're either going to share them to become full or complete, or they're going to lose or gain them to become full or complete. How do you know an ionic bond versus a covalent bond? Remember, ionic bonds, you're going to have positives and negatives. So you're going to have a metal and a nonmetal. If you have a metal and a nonmetal, you're going to have an ionic bond. Do you remember what you're going to have for a covalent bond? You're not going to have a metal. Covalent bonds aren't found in metals. You're going to have 2 nonmetals. Okay, and these last ones, draw electron dot model for a covalent bond. Nope, we're not going to do any of the drawing on this test. Draw an electron dot model for the ionic bond final structure. Okay, that's not going to be on the test either. So we're going to conclude with this, and that is your study guide.